Yeah, I'm going to talk about revolutionizing automotive with Qt, which I think is the theme for this room, it seems. I work with a company called Pelagicore, and these are basically our sales pitches. We want to put stunning UI in automotive, and we want to do it with Qt. And we also want our customers to experience change, not only in the way that we develop software, but in the way that we interact, the way that we can talk to interaction designers early and throughout the project, and the way that we build and execute the whole project. So what is infotainment? I think most of you know it. I just wanted to show this picture. I looked for a good interior picture, so this is just a random car. But this is what you're faced with as a driver. That is infotainment, your whole environment where you're actually at while driving. So it's a huge part of the impression that you get from the car, especially in everyday driving. I'm one of the guys who likes torque and rear-wheel drive, but you never use it. I mean, this is what you use for real every day while commuting. So Pelagicore, we call ourselves an open source company. And in this business, there are basically two Linux initiatives. There are many more, but there are two major ones. There's Geneva, who's a standard body, which we're a member of, and there's AGL, the automotive-grade Linux project run by Linux Foundation, also creating a Linux stack that sort of fills the gap for the automotive business. Funnily enough, AGL targets to be Geneva compliant. So it's more or less a joint effort, I'd say, from a practical standpoint. I'm sure other people wouldn't agree, but the outcome will be the components that are missing in an ordinary embedded system to build an automotive infotainment system. Both these projects build demonstrators. We also build demonstrators atop of these platforms. You can see one downstairs with our components on top of the standardized platforms. I said that there are gaps in embedded Linux. There are things that we do differently in automotive, and I mean, the devil's in the details. It looks the same. It's a device, basically, but there are more challenges. We as a supplier have different requirements when we put the software into the car and sell it as a part of car. If somebody dies by surfing the web, we are liable. If you bring your iPad in and surf the web, we are not liable. So we are faced with legal challenges, safety requirements. There's a lot of work going on with driver disruptions when it comes to autonomous vehicles. This sort of links into infotainment because that's probably where you're going to spend your time. So how do you do the handover when things become complicated? How do you reliably get the driver to take over responsibility? There's a lot of details around this. And then we have the whole industry itself. I mean, there are technical issues, sudden loss of power. You slip the clutch while you're at some strange location where you've never been before in your rental car. Stall the engine, restart. You want the navigation to start pretty quickly to know where you're going. That falls into boot time. And then you have the worst case of boot time, aborted shutdown. We hate that. You turn the key, we haven't saved everything to flash, and you start again, and we still need to be up within the legal limits. You need to have that rear-view camera up in 2 seconds, for instance. So you need a full video stream with overlays really quickly. Flashware, you use your phone for 9 months, 18 months, 3 years. You use your car for 10, 15 years. We can't burn that flash out. Latencies, again, take the rear-view camera. That video stream has to be pretty live. It has to be following the reality. Then we have the whole project part. Lifetime of project, I mentioned 10, 15 years. Length and size of projects. I mean, we speak 3 years project time, many hundred engineers, approaching like the 50 million euro mark. Complex supplier relations, you have tier 1s, tier 2s, OEMs, everything has to be merged, everything should be replaceable and fit. You might create a head unit where you have different suppliers for the amplifier systems, and you need to sort of initialize the amplifier systems to do your beeps while, again, using the rear view camera. Lots of details and purchasing and, yeah, requirement specs. As an engineer, I can't really understand why the behavior when you insert a broken CD defines the car, but some brands are really specific on how many times you have to retry before ejecting it, and yeah, there's details. But we built something for this. We built something that we call the Pelagic stack. And we try to say that it's a modern stack. It's an application-centric stack. So we start down here with Linux, CPU adaptations, ECU adaptations. Generally, we start with the Octo project, so open embedded. We add a component that we call Application Manager. I'm going to dive deeper into this, but that's the enabler to do multiple processes and compositing and forwarding events and stuff like that. There's a whole bunch of services. Some are open source. I put Geneva there. Could have said AGL. Could have said something else. Generally, you mix and merge. Some OEMs have existing relationships with suppliers of specific functionality. They want a specific navigation engine, a specific Bluetooth stack, things like that. So you have to be able to integrate different service implementations for different projects, basically. Then we have a container solution, which is non-Qt. It's more generic Linux, so I'm not going to mention that much more. It's Linux container, but in a more convenient way. We have something that we call Qt IVI, which is an abstraction layer, providing a Qt feel to all these interfaces that we have underneath. And then on top of that, you have the gray stuff there, the OEM specifics. You have applications, and we have something that we call the system UI. So basically the graphical shell, your window manager or Wayland compositor, so to speak. Apps in cars is a funny topic sometimes in this industry. Traditionally, you do a big UI with a state machine under it. Potentially, you disable parts depending on how much you pay for the car. Doing apps is difficult. It's a different approach. MirrorLink was fun when I started to go to Qt Dev Days down in Munich. Must have been 5-6 years ago with Nokia. It's been tried before. Now we have Apple CarPlay and Android Auto doing this again. It's great. I think certain use cases definitely work better if you can carry them out of the car. But as all the previous speakers have said, who owns the data? The data is really, really sensitive. And I mean, the automotive industry lives off aftermarket. It's windscreen wipers for 40, 50 euros. That's big dollars in the end. So there's a demand for native applications. There's a need for native applications. And it sort of unlocks some of the things that we've been listening to during this day. We can add apps or update apps during the vehicle lifetime. You don't have to go to the workshop to upgrade the whole head unit. You can download the new version of Spotify or something. And also this more and more matches the expectations on how you add content to your devices. The popular word is millennials, and I mean, they live in an app-driven world. They expect everything to be an app. And then we have nice side effects. Smaller updates, cheaper updates, easier to validate. You can partition the UI in exchangeable parts, so if you want different ranges for different price points, you can add that as apps. So you have the same underlying platform that you validate once and deploy once. So we enable apps with something that we call the Application Manager. It's a great name. So the key focus here is multi-process. So each app runs as a proper separate process or set of processes, even if you want that. If you choose to go with a container trail, it also runs within its own Linux container sandbox. So it's basically completely self-contained from the system. We can control what it can actually access. The application manager is responsible for lifecycle management, both the big one, so to speak, installing, removing, updating, but also the runtime lifecycle, so starting, pausing, unloading, stopping, all the states that you need for an application while being executed. We have a security model, so when you deploy apps, we can tell that it's actually from a trusted source. We can also ensure that the Windows services come from an application that we trust. We generate basically a one-time hash that the application has to hold on to, and you as an API provider can request that back, and then you know that it's not just the same PID or something like that, it's the actual app that you launched. It's a Wayland compositor based on the Qt Wayland compositing engine. So we have all the nice bells and whistles that QML2 gives us, all the magic stuff. You can do shaders and stuff on your apps without telling the apps. And you sort of do a layered approach. So we have everything from the application services. We can put on-screen keyboards or handwriting recognition areas on top of it. We can put notifications outside of the apps on top of them, and then we compose that into a single view that's actually presented. And what we're trying to do is really to bring Qt from being an application framework to actually being the platform for doing apps and UIs. So looking at the responsibilities, the simplified view of Application Manager is that it does 4 things from a technical perspective. So we do Wayland compositioning with this token-based security mechanism, so we can actually validate that the surface comes from the correct sender. Something that's closely related to the compositioning is input management. So we route the input events, basically. Those two usually are tied together, even though button mapping can be kind of interesting in automotive cases where you have functional buttons, like the play pause button that goes to the media player, regardless of where you are. It acts as a launcher with responsibility for runtime. So we can tell our applications that you need to start unloading all your graphics caches, for instance, because we need the memory. And then we do security and lifecycle. So containers, installations, validation of packages, making sure that they're signed by a trusted party. Then I just wanted to go into a rough architectural diagram. The application manager itself, the actual compositor, runs as a process with very few writes. It relies on 2 support processes. The installation helper, that's allowed to write to Flash, where we store the applications. And then we need another one that's allowed to read and set up sandboxes. So we sort of separate those functions, which means that we don't pitch it as a security solution per se. The key point is flexibility and convenience rather than being super secure. So it's not like banking software is secure, but we make an effort to sort of separate the different functions so that as long as the kernel behaves as it's supposed to and the surrounding system, it should be safe. You shouldn't have malicious code running down here being able to update another application, things like that. It's only for that runtime instance. 10 minutes left, speed up. Another big part of this, apart from application management, is the platform APIs. And what we've come to learn over the years is that platform APIs are really, it's more of a pattern than a common API. There are multiple efforts, and I encourage them to try to define a common API for being able to move applications in between cars, within the same OEM, or even between OEMs. But from our experience, it's more important to create the pattern, to really have a clear way of how we do this, because there will always be changes made to it. So we provide something that we call Qt IVI, that provides what we call features, which are basically Qt and QML modules exposing a feature API upwards. These features rely on the Qt IVI core, which is where most of our generic code sits. That provides base classes that lets these features find their backends dynamically. So that we can load the right backend when you're on the target, but we can also load a different backend when you're on your desktop PC. And here we have a feature scope where we want to cover the same. Did this one die? No? The same features as the W3C Automotive APIs, roughly. They have APIs for controlling windscreen wipers, which I don't think has to go into IVI, for instance. Is it on? Soonish? Now it's on? So what we're doing here jointly is to Qtify these APIs. You start with the JavaScript navigation object at the bottom, and then you sort of move your way up towards your actual feature if you work on the website. We want to be able to instantiate climate control. And that's an object with properties and signals and slots and models where applicable and so on. So it's a proper Qt feel to the APIs. Then the W3C standards add a couple of nice things. So optional features, for instance. For climate control, let's go for zones first. Zones means that you can have a climate control object for each zone in the car. And you can enumerate those zones. And that also means that some features are only available in certain zones. You might only have seat heating in the front seat. The steering wheel heater is definitely only in one zone, I hope. And again, we try to Qtify this. So looking here at the climate control object, it exposes a model of the zones. So that gives you all the zones and all the climate control properties down there. But then we've added an attached property called zones. So this one has a nice base class that this one knows of, which means that you can also bind into that model directly, so you don't have to add a lot of JavaScript. The end goal is to really have a Qt QML feel to the APIs, even though we're covering the same scope as the W3C APIs. And just a quick word when it comes to backends. Having an API, a platform API, is really what drives the ADK. So the application developers always work here. And one of the nice or strange things with automotive is that you generally have very few target environments, at least complete ones. You don't give a car per application developer. So it means that we need to be able to do these things. And having dynamic backend loading means that this is dead simple. We can always have stubs sitting down there. But we can also go here and start interacting with the device emulator, which is a part of the commercial offering, so that you can automate the backend. You can script those or toggle them as a developer using a GUI. While we at the same time document this as the outgoing API, we can also provide black box testing from the top down, so we can ensure that these two behave reasonably similar. And that brings us to the third part, the ADK, or application SDK. We build, all our customers want an ADK basically. You want to be able to scale development. So we create one based on the Yocto SDK, on Qt Creator, on the installer framework, but we also add our own tools like QML Live. And we also have a reference UI, which you can see downstairs, that is built using this. QML Live is really just a reloader on steroids. So when you save your QML, it reloads. And if you have two screens, that's great because the window doesn't pop up on the wrong screen every time you start your QML application. It stays put. But it's server client. So you can run the reloading part on your target. So you can get the right hardware, the right backlight, the right touch performance, all of those details. And you don't need any skill, basically. You find it automatically through a GUI. So you can hand a target with QML Live running on it to your designer and have them use Qt Creator. And it's basically a pairing sequence that you do, and then you have your UI on the target live for you to try with the right GPU, so you don't do silly stuff that brings down the frame rate, for instance. It's open source. You can get it on GitHub. Feel free to improve it. We think it provides the quickest turnaround times you can have. We've had customer examples where we've reduced the turnaround time from 6 weeks to 400 milliseconds. So that was a bit of an extreme case. It really changes the way that the designers can work. I just wanted to show you a couple of screenshots. We have this live downstairs. We call it Neptune. It's our reference UI. This would be the center stack, so classical infotainment. And then we also have a cluster being run from the same hardware. So yeah, here we have the same navigation data feeding to different views, for instance. Returning to this one, the news today, I think it was announced last week, the Qt Auto Suite. I just want to map this onto a different diagram where we can see that the different parts fall in. So we have Qt IVI, we have the application manager. I actually left out the containment stuff because it's not Qt related. I guess it's somewhere here, architecturally. But this is what takes us here, jointly with KDAB and the Qt company. And that's basically what I have to say.
Thank you. We still have time for one or two questions. I don't see anyone directly, so I can bring up my own ones. That is basically toward the Wayland world, which might not be surprising. You said you use the standard Wayland protocols. In Western, there are special Ivy protocols. Do you also use them?
Not at the moment, no. We use what's available through the Qt Compositor APIs. We have been in contact with a working group doing the IVI extensions, and we know that there is a patch for code review. I don't think it's making a lot of progress right now, but it's being worked on from the big Qt side, so to speak.
All right, and no, we have a few questions.
When you brought up driver disruptions, how do you protect for that and allow application developers to bring in their own applications?
So basically what we do is that we centralize the compositioning in the system UI, which is executed as a part of the application manager process. So we provide the tools. You can validate that a Windows service actually comes from a trusted source. It's not just any Windows service and so on. So we more enable you to do it than actually do it.
We had one question over here somewhere. Ah, wonderful. So, yeah, we still have perhaps time for one more question.
All right, thanks for the great presentation. Just curious, so this is more focused on the UI parts of the vehicle and infotainment, but do you envision something that would extend all the way to easy use even in terms of creating more full functionality or full features?
Well, we as a company do a full platform, so we try to stretch all the way down. The focus here is Qt, which sort of falls into UI. We've been experimenting with the idea to also use Qt and the same platform abstraction for headless services. But we don't see a lot of traction for that right now. Qt is more attractive from a UI standpoint at the time being. But doing different abstractions of the platform for headless services and visual services doesn't really make sense. So let's hope.
All right. Thank you for the very interesting talk. And if you leave